This is Euclid Book 10, proposition number 2. And here's the illustration. Okay. And it says, if, when the less of two unequal magnitudes is continually subtracted in turn from the greater, that which is left never measures the one before it, the magnitudes will be incommensurable. For there being two unequal magnitudes, AB and CD, and AB being the less. Now what does that say? Okay. We have two lines, AB and CD. Obviously, AB is not as long as CD, and that's what they were trying to say. They're not the same length, and this one's not as long as this one. That's what they're saying. That's what Euclid is saying. Okay. When the less is continually subtracted in turn from the greater, let that which is left over never measure the one before it. I say that the magnitudes AB and CD are incommensurable. For if they are commensurable, some magnitude will measure them. Let a magnitude measure them, if possible, and let it be E. So now we're going to say, hypothetically, that E can measure both AB and CD. Let AB measuring FD leave CF less than itself. Okay? So, AB is going to measure FD. But when it does, it's going to leave this little remainder, CF, which is not going to be as long as AB. Okay. Then we're going to let CF measure BG and leave AG less than itself. So, CF is going to measure BG, but it's going to leave this little part behind called AG. Okay. And let this process be repeated continually until there is left some magnitude which is less than E. Okay, so here's how this was working. We first take AB, and it successfully measures CD, but it leaves a remainder CF. And then we take CF, and we measure BG until all that's left is AG. Eventually, AG will be less than the measure of E. Okay, AG is not as long as E. That's what we're saying. Suppose this is done and let there be left AG less than E. While AB measures DF, therefore E will also measure DF. So E is now going to be able to measure this line without leaving a remainder. But E measures CD also. So now we're saying that E measures this and E measures all of this. Therefore, it will also measure the remainder CF. Well, if E measures CD and E measures DF, then E is also going to measure CF. But CF measures BG. So this line here measures this line right here. Therefore, E also measures BG. Now we're going to say that E measures this. Not too bad so far. But E measures AB. So now we're saying that E measures AB, E measures BG. And if that being the case, then we're also going to say that E is going to measure AG. So now, we're going to have, let's say, hypothetically, just hypothetically, let's say AG was 2 and E was 3. Now we're going to say that 3 measures 2. 3 doesn't measure 2. That's a problem. So therefore, no magnitude will measure the magnitudes AB and CD. Therefore, the magnitudes AB and CD are incommensurable, which is by Euclid Book 10. Okay, it's by Euclid Book 10, definition number 1. And that is the whole proof. I will tell you more in a future video. Stay tuned.